This is one of several videos to where we're going to look at the equations of circles. And before we start talking about the formulas for the circle, let's first define what a circle is. And most of us know this. But a circle is going to be the set of all points in a plane that are equidistant from a fixed point called the center. And distance is called the radius. Okay, so if we have the center of a circle, and these are all the points that are fixed and equidistant, so basically this distance, and I know it's not a good drawing, but this distance, those are all the same distance, which we call the radius. Okay, so those are all the radii of the same circle. Now, think about this. If I were to call h comma k x1, y1, and x comma y, which is any point on the circle, x2, y2, I could find the distance of that formula. Okay, so we could say that the distance d is equal to the square root of x2 minus x1, which would be x minus h squared, plus y2 minus y1, which would be minus k squared. And then if we were to square both sides of this equation, we would say that the distance squared is going to be equal to x minus h quantity squared plus y minus k quantity squared. And remember that the distance is the same thing as the radius. So d is equal to r. So we could just replace this with r squared equals x minus h squared plus y minus k squared. And that's actually going to be the formula that we use, okay? It's actually this formula that we have up here. So the equation of a circle is based on the distance formula, okay? That's how we can derive that pretty easily. So essentially, what we're saying is that if we have an equation of this form, all we're saying is that r is the radius, and we're saying that h comma k is the center of the circle. Okay, so just looking at this formula. Okay, and sometimes it's put into that formula, and sometimes it's not. We have to do some manipulation and some algebra to be able to put it into that form. All right, so let's go ahead and both build the equations of circles, but then also try to go backwards and try to identify key characteristics of a circle just given the equation. Okay, so let's find the equation of the circle, get with the given information. So we have a center of 3, 4, and a radius of 2. Okay, so the center, which we just said was h comma k, is going to be 3 comma 4. And so what that means is 3 is h and 4 is k. Okay, so we have that h is equal to 3, k is equal to 4, and that the radius r is equal to 2. And so if we wanted to plug everything in right into this formula, we would have x minus 3 quantity square plus y minus 4 quantity square equals 2 square. And of course, we know that 2 square is going to end up being 4. So we probably want to just simplify that and make it into a 4. Okay, I'm just going to put a note right here that that's 2 squared. All right, and that's going to be our equation of the circle. Okay, so really easy. So if I were to look at this, I would say that there's a center of 3, 4, and the radius is 2. Okay, and we're going to do that a little bit later once we start going backwards from this stuff. All right, so now the next thing we're going to do is we're going to have the exact same thing, except we have some other not so nice numbers here. So we have a center of -2, 4, and a radius of 7. So we know that h is going to be -2. We know that k is going to be equal to 4, and that the radius is the square root of 7. And so one way to write this would be x minus -2 square. So that's h minus k. So going back up to our formula, we have x minus h quantity square, excuse me, plus y minus 4 squared is equal to the square root of 7 squared. And remember, that's just because we look at our formula and we have an r squared in this formula, okay? Now, we could simplify this just a little bit more because we certainly have a double negative. So we have x plus 2 squared plus y minus 4 quantity squared, and the square root of 7 squared is just going to be 7. So this is probably the cleanest answer that we can get without foiling things out. A third example, this time we have a center of 1 comma 2 and a point 46 on the circle. All right, so let me just quickly draw this so that way you can see, and just imagine that it's somewhere in our Cartesian plane. All right, so we're going to draw this. And let's say we have the point over here. Let's say this is our point 1, our center, excuse me. Let me erase that really quickly. So this is our center right here. That's the point 1, 2. And then somewhere over here, okay, is the point 4, comma 6, okay, not to scale. And so one thing that we know is that to be able to figure out the equation of a circle, we need two things. We need a center, okay, so that's good. But the thing that we don't have is the radius, okay? But the radius is going to be from here to here, okay, or close enough to that. Sorry, it's a little bit more than that. So let me try to redraw that just for sake of accuracy. So, and that's just going to be the distance, okay? So our radius is going to be our distance between those 2 points. So I think what we should probably identify first is that h is 1, k is 2, and then the radius is going to be the same thing as the distance that we can formulate between these 2 points. Now, let's call 1 x1, let's call 2 y1, and let's call 4 x2, and let's call 6 y2. And we could just substitute everything back into the distance formula. So the distance d is going to be equal to the square root of 4 minus 1 squared, so that's x2 minus x1, plus 6 minus 2 quantity squared. And so if we simplify this, that's the square root of 3 squared plus 4 squared, or that's going to be the square root of 9 plus 16, which is square root of 25, which is 5. Now, 5 is going to be the distance d, which is the same thing as the radius. Okay, so radius, which is equal to d, which is 5. And now the last thing we're going to do is we're going to use our formula for the circle. Right? So we go back up here. We have our equation of a circle, x minus h squared, y minus k squared equals r squared. So one way to write this would be x minus 1 squared. Okay, so that's x minus h plus y minus 2 squared is equal to the radius squared. Okay, or to finish this off, we could say x minus 1 squared plus y minus 2 squared equals 25. And that's probably the best, most simplified answer we can get without foiling things out. One final example before we move on to another video is we only have the endpoints on a diameter. Okay, so we have a 1, 2, and negative 3, 10. All right, so let's say for some reason we have a circle. All right, and again, not drawn to scale, but we have a point right here that's 1, 2, and then we have another point up here. Let's call that negative 3, 10. And these are the endpoints on the diameter. All right, and let's just assume right here is going to be the center. All right, so if we found the distance of this, okay, so two things we noticed. We don't have the center and we don't have the radius. And so if we found the distance between those 2 points, that wouldn't necessarily give us the radius. It would give us the distance, the diameter. And also, to find the center, we don't have the center. We just have the 2 points on the ends. But one thing that we notice is that the center is going to be the midpoint of those 2 points. All right, because remember, on a diameter, the diameter goes right through the circle. And so that means that to find our midpoint, which is our center, that's going to be, if we call this x1, y1, and we call this x2, y2, and it doesn't matter which one is x1, y1, which point is x1, y1, and which point is x2, y2, as long as we keep ones with ones and twos with twos, the midpoint is going to be negative 3 plus 1 over 2, comma, and then 10 plus 2 divided by 2. Or that's going to be negative 2 over 2, comma, 12 over 2, or negative 1, comma, 6. And so we know that h is going to be 1, and we know that k is going to be 6. So let's hold on to this. Next thing we need to do is we need to find distance. All right, so in our circle, let me erase a little bit of stuff up here. In fact, let me just erase the entire thing. We can just replot it really quickly, just because I got a lot of stuff going on there. So we have our circle, all right, and then we have this point up here, which was negative 3, 10. And then we had the point down here, which was 1, 2. And then we had the central point, which we called 1, negative 1 comma 6. Now, what we could do is we could find this distance, okay? So I'm going to call this d, which is the radius now, right? So let's go ahead and see if we can find what the distance is. Our distance d is going to be equal to the square root. I'm going to call this now x1, y1, and x2, y2. Okay, so I'm just redefining those because now we can just go ahead and find the distance pretty easily. Right? So that's going to be 1 minus a minus 1 squared plus 2 minus 6 squared. And then this just becomes square root of 2 square plus negative 4 square, which is going to be equal to the square root of 4 plus 16, or the square root of 20. All right. Now, we could simplify this. All right. We don't have to in this case, but we probably should just make sure that we can, because we know the square root of 20 is 4 times 5, and we could write that as 2 roots of 5. But I'm just going to keep it like this, because that way when we square it, we don't have to do any extra algebra except for getting rid of the square root. So this is our radius r, because it's our distance. And so our formula is going to be x minus a minus 1 square. Okay, so that's our center point of H, plus y minus 6 square equals the square root of 20 squared. Right? Or a little bit cleaned up version would be x plus 1 square. Y minus 6 quantity square is equal to 20. All right, and that's going to be the equation of our circle. Okay? So be cognizant that these equations of circles sometimes require our distance formula and our midpoint formulas. Okay, so make sure that you're okay with these before we move on to the next section.